Hello guys, welcome back. So here we have another question from GATE 2018 on network theory. So the voltage V of t across the terminals A and B as shown in the figure is a sinusoidal voltage having a frequency omega equal to 100 radian per second. So this is having some omega equal to 100 radian per second. And when the inductor current I of t is in phase with the voltage V of t. So when I of t is in phase with V of t, the magnitude of impedance Z seen between the terminals A and B is dash. So when I of t in phase, meaning what are you changing here? You're finding L such that your V of t and I of t are in phase. So during that case, they are asking what is the impedance Z. So let us go to the Fourier domain. So here you have a capacitor. What will be the XC of it? The impedance? It will be 1 by j omega C. So 1 by j into omega is 100 radian per second and C is 100 microfarad. So 100 into 10 power minus 6. So this is nothing but 10 power 2 into minus j. So this is minus 100j. So here if you see effectively this is like minus 100j in parallel with 100 ohms. So minus 100j in parallel with 100 ohms. So this is equal to 100 into minus 100j by 100 minus 100j. So 100 I can cancel. So it is minus 100j by 1 minus j. And this I can multiply and divide by 1 plus j. So I'll get minus 100j plus 100 divided by 1 square plus 1 square, which is 2. So it is 50 minus 50j. This is what I get. So this is my effective impedance here. So what will be the total impedance? So I have some L. This is I of t. And then I have 50 minus 50j. And this is my V of t. So when will my I of t and V of t be in phase? If the Z is purely resistive. So if Z is purely resistive, then my I of t and V of t will be in phase. So if it is purely inductive, then it will be, if it is purely inductive or capacitor, it will be plus or minus 90 degree out of phase. If it is inductor plus resistor, it will be somewhere in between 0 to 90, right? When will it be 0? The phase between I of t and V of t be 0. It will only be 0 when this Z is a resistive network. So here if you see, this is nothing but j omega L. Z is equal to j omega L plus 50 minus 50j. So for this to be purely resistive, this should be some R plus j into 0. So if you see, your j omega L should be equal to 50j, your omega L should be equal to 50. So which means that your L should be 50 by omega. Omega is 100. So it is 0.5 Henry. But in this question, we are interested in what is the Z. So if you see, it is only the real part of this. So Z should be equal to 50 ohms. So this is your answer, 50.00.